Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome all of you in today's workshop. The Artificial Intelligence and Data Analytics Lab at Prince Sultan University has organized the technical training workshop program for the community. Under this program, you can enroll in different workshops. This time, we are offering 2 workshops. One workshop is today, inshallah, about data visualization using different libraries in Python. And the other workshop will be scheduled next week, inshallah, same time at 4 p.m. about Microsoft Azure Machine Learning Studio. Let me start by introducing you to the instructor for today, Ms. Safiya Dawood. Ms. Safiya has completed 2 master's degree, one in computer science and the other degree in health informatics from King Saud bin Abdulaziz University for health sciences. Her bachelor degree is in computer science. She has more than 4 years of experience in the following domains: statistical analysis, data visualization using R and Python programming languages, data managing operations, including data extraction, transformation, loading, data wrangling, and exploration. I'll be sharing with you the attendance sheet. Please make sure you fill the information correctly so you can receive the workshop material, recording, and your certificate as well. Ms. Safiya will be with you the whole session. The floor is yours, Ms. Safiya. Please, you can start.
Thank you, Ms. Hind. Thank you very much for this introduction.
Thank you, Ms. Hind. Thank you very much for this introduction.
And also, I would like to thank Artificial Intelligence Data Analyst Lab for this opportunity, and the entire Prince Sultan University for supporting such workshops. Also, I would like to thank the audience for taking from their time to attend this workshop, and I hope it will be useful and meaningful to them and very smooth. Today, we will talk about the workshop titled Data Visualization in Python. We will include different visualization using different libraries offered by Python, including Matplotlib library and Pandas and Seaborn. We will talk about some of the tools like Jubiter and Anaconda. We will talk about the installation, and we will implement practical examples for visualization. This workshop will be as a beginner level. It's give us the basics and the basic information and introduction to data visualization.
Ms. Safiya, sorry for interrupting. Some of the audience are saying that your voice is very low. I would appreciate if you can just raise it up a little bit.
Okay.
Thank you.
Now I will talk about, as I was saying, that this workshop will be a beginner level for data visualization using Python. I expected that the audience used some languages and know a little bit about languages, any language, for example, C or C++ or Java. Just experience some languages. It's a beginner level. Okay. The outlines, we will talk about data visualization. Why data visualization? What are the benefits of data visualization, data visualization techniques, and we will have a practical tutorials and exercises using libraries offered by Python. First of all, data visualization. I think all of us here know the importance of data visualization, and data visualization can be defined as the process of converting raw data into easily understandable vectorial representation that enable fast, effective decisions. It's both art and science. Data visualization is a strategy where we represent the quantitative information in a graphical form. Data visualization is very important in every field, in the scientific research, in financial, in economical, in business. We use data visualization daily. It's the basis for analysis, the first step for every research to describe the data. Okay. Uh, Next, why data visualization? Pictorial form of data is easily understandable rather than huge numbers of numerical data, and we cannot argue about that. That a picture is worth 1,000 words, and picture usually and graphics is easier to understand, easy to analyze, easy to extract decisions and conclusions and use them as evidence. Data visualization is the first step of analysis work. It gives intuitive understanding of data, help you to see data in a certain meaningful patterns. Visual representations enhances the human cognitive process. And all of us agree about the benefit of data visualization. And as we go through the examples, every research and every, not to just focus on research, every dashboard, even for users, they need what visuals to depict the meaning behind the data. Okay. Benefits of data visualization, as the image in front of you give us some insight that every data have different perspective. For example, when you look at data as a researcher, you need a different view than a consumer, than a user, than a manager for decision making. For every data need must be viewed differently and have different perspective according to the need of this. We will discuss here the data visualization, allow users to see several different perspectives of data. Data visualization makes it possible to interpret fast amount of data, and this is very accurate. For example, during COVID-19, daily we have multiple records may reach hundreds of thousands of records. We will extract patterns and conclusion from these data using visualization. It offers abilities to note expectation in data, okay, exploring trends within data databases through visualization by letting analysts navigate through data and visually orient themselves to the patterns in the data, and this is concerned with the pattern recognition among vast amount of data and databases, big databases. We find ourselves needing visuals that summarize and find the relationships about and patterns among data, collected data. Data visualization techniques. I think most of us heard. We went through this. Crossed path with some of these techniques. For example, bar chart, histogram, scatter plot, pie plot, hexagonal plot, and area plot. And there is heat maps and others. We will go. We will implement some of them, inshallah, during this workshop. Data visualization. Now we'll talk about data visualization with under the perspective of Python. Python provides different libraries. If we write in Google, for example, data visualization libraries, then we include Python, we will have multiple libraries. Since Python it's an open source and developed daily, and included different methods and different specification from programmers. We will talk here, will include Matplotlib library, Pandas, Seaborn. We will talk about Plotly. Plotly for interactive, is mostly used nowadays for online dashboard, okay, for interactive users, NumPy, and Anaconda, Jubiter, and Notebook. There are others, but we will include as a beginner level these libraries. Python. Now we'll give a brief about Python. Python is a general purpose coding language, which means that unlike HTML, CSS, and JavaScript can be used for other type of programming and software development. Besides, web development that include back-end development, software development, data science, and writing system script, among other things. Python, actually, Python can deal with data sources, reach the data, clean the data. I can through using Python to clean the data, and then represent it, and then publish it on a front end applications written by HTML, JavaScript, and CSS, and so on. So Python, it's similar to other languages that sometimes we call it the glue that glues the back end with the front end environment. That's why nowadays, especially, we hear Python. We can in mobile applications, or in data science, machine learning, and research in big data and everything, because it have the ability to collect data from its sources, clean them, process them, and then display them in an environment, JavaScript, CSS, and HTML, and anything. Okay, this is Python. We'll talk about Jupyter, as I included I talked about it in a previous slide. Jupyter Notebook, I included here because it's important for programmers, Python programmers in general. It's an open source web application that allow you to create and share documents that contain live code, equation, and visualization in a narrative text. Okay, why we call it Jupyter Notebook? It's used by the coders of Java, often by Python coders, especially, to create codes for a narrative context. What do you mean by narrative context? We will see next in the examples. You can create, for example, I extracted the code from a distributed database, then I want to see this code. Okay, this is how I narrate my coding. My coding will be as a narrative. I connected to a remote source, I extracted the data, now I want to see the data. I didn't do any processing to it. Okay, then after seeing the data, I want to, for example, do a classification method on it. Then I want to see the result as a narrative text. We will talk, inshallah, and we will implement simple examples on Jupyter Notebook. Uses include data cleaning, data transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. Jupyter Notebook considered as a text editor for Python codes, a text editor for Python code. That means we have like any other language. If you are familiar with other languages, for example, C, Java, any other web application development, we have different editors from different companies, some of them commercial, some of them open source. But according to the coder himself, he or she can prefer which tool to use. Okay, this is when I mentioned Jupyter Notebook here, this is not exclusively. There are other tools and other editors. There are Visual Studios and so on. Okay, you can run Python code on it. But Jupyter make it easier to publish on the internet. Your tool, for example, I created a dashboard that follow a disease statistic. You can I can easily publish it on the internet and see the result on a web page. Jupyter Notebook do that. Anaconda. We will talk about Anaconda is a distribution of one Python R programming languages for scientific computing that aim to simplify package management and deployment. The distribution of it includes data science packages suitable for Windows, Linux, and Mac OS. Anaconda is a distributed executable file for help us integrate R with Python and its library. It's easier for this. And we will use it to install Jupyter on our devices using Anaconda distribution. It will be easier than installing dependencies alone and then prepare the environment. Like it's executable file, immediately prepare the environment for us. Installation. Now we'll talk about the installation steps for Python and Jupyter. Okay, for Python, okay, I need to download the uh, the executable file from python.org. Python.org can provide you with very valuable information and documentation about Python. Also, they have community to follow up the new trends and everything related to Python and libraries, and if there is update on anything. Okay, you can download any version you want for either for according to your operating system, Windows, Linux, Unix, Mac OS, and others. Okay, I latest version, and it's an executable file. Give me 1 minute. Okay, here's the executable file. It's easy Python 3.9. You can double click it into executable. Next, a dialog box is next you specify the location. It's very straightforward, and you will have you will ask you to specify the folder for installation and then finish, and it will be installed. For it will install only the terminal command for you. Okay, as we said, python.org. Also, for Jupyter, okay, for Jupyter, we used depend on Anaconda, as I mentioned before. It's distribution that will include different tools for Python that prepare an environment for Python for online development. And include also visual libraries, and some of the libraries are missing, but you can add or remove in any libraries you want. You can go to anaconda.com. The same. Okay, welcome to Anaconda. Anaconda provide also tools for machine learning, AI, and this is not our specialty in this workshop. We only focus on downloading Anaconda for. I downloaded it for Jupyter to check it together. Okay, then after installation, also it's a straightforward step. Next step as Python installation. You download the executable file. Then what next until you finish it. This is the installation for Python, not the libraries. Then we will now we will start with the libraries. The first library we will talk about is Matplot library. Matplot library is a graph plotting library of Python. Using Matplot library, we can plot different scatter plot, line graphs, bar graphs, pie chart, and histogram. Okay, the basic considered Matplot is considered the basic visual library for Python, and other libraries such as Seaborn and other libraries, visual libraries, Plotly, are built around this Matplot. The base is what? Matplot. It provides an object-oriented APIs for embedded plots into application using general-purpose graphical user interface. And here I mentioned some of the some of the development environment, tkinter, Qt, and others. Those provide built over Matplot and provide a visual representation. You can create visual interfaces based on Matplot. But the basis for these graphical user interfaces is what? Matplot. Matplot. To install Matplot library, we will use the command pip, short for Prepared Installation Program. Install, then I write the library. This applies to Matplot and any other library, either for visualization or not. Any library that need to be installed in Python, we will use this command, which is pip install matplotlib. Okay. Also, we will install Pandas. Pandas, the other library we'll talk about, using the same command, pip install Pandas. Okay, here I give some one comment about Panda. It helps enable you to carry out your entire data analysis workflow in Python without having to switch to a more domain-specific language like R. Panda is considered Pandas is considered a data visualization library, but also it provides data analysis and handling resources and data. It have a special read, comma separated value data source, and can upload these columns into your working area, and you can see these columns and print them and manipulate them. This is Panda enable you to manipulate data sources, as we see inshallah in the next examples. Now we will try how to install it. Panda install Matplot. Okay, according to the environment you're working on, sometimes you have different area, different terminals you can write your command in. Okay, but I will use one of the method and how to install a library. First of all, I need to go to the command line interface. I'm talking about Windows. I'm using Windows 10. Okay, the same Linux in Mac operating system. You can use the terminal or shell. Okay, I'm going to DOS command line interface. Okay, the command line interface. I need to navigate and change the directory to the directory where I installed my Python library, my Python installation. Okay, when we installed previously, I downloaded Python executable file, and then I installed the Python. The dialog window asked me where to want to install it. Okay, I think no one know where I install it. When I install it, where I know I installed, I write IDE. Sorry, Python IDE. Integrated Development Environment. IDE is short for Integrated Development Environment. I'll open it, and this is what the terminal of Python. Now I need to know where is this Python downloaded on my machine. Okay, okay. I'll go by Control S, saving. I want, for example, I want to save the file. Okay, it will save it on the main directory for Python. This is my Python main directory where it's saved, where it's installed. I'll copy the address. Then I go back to the command line interface and write change directory and paste the address. Here the address is C users app data local program Python 39. This is where I installed my Python distribution when I downloaded, and when the installation dialog box asked me where to install the Python tool. Okay, maybe it differed from one device to another device. Yes. How to know it? You go to the Python shell and then write Control S save, and you can figure it out. If you know where is the location, you can type it immediately. Change directory. Then I want to change the directory. Okay. Now I want to execute the command pip install matplot. Okay. I will write the command Python -m pip install matplotlib. Okay, Python for it will trigger, the command will trigger the module Python inside the operating system to choose the suitable installation module inside the dependencies and install the library matplot. The library, if it's not inside within the folder, the main folder, installation folder, it will be extracted and downloaded from the Python repository, python.org, where we downloaded the executable Python distribution. They have library repositories. Okay, when I write the matplot, it will connect to the internet. If it's not inside my device, it will connect to the internet and connect to the repository, search for the dependencies for this lab and this library, and this what download it into my computer. This is the same technique used by Linux if you work with Linux, or because all other open source application and environment. Okay, then I press enter. It's written here the message, the result of this command: requirement already satisfied. Why requirement already satisfied? Because I installed what? The library. I already installed it before, but if you the first time install this library, it will you have a message. The dependencies for this library and metadata will be downloaded, and then we'll start installation. And at the end, you will get the satisfaction message. Okay. Any other library, for example, Pandas, I will write the same command: Python m, okay, pip install pandas. Okay, again, this command will communicate with the operating system, use the Python module on this machine to find the appropriate installation to install this library. If it's not available in your machine, it will be connected to the python.org repository and will install, download the dependency and install the library. Okay, I'll press enter. The same message here happened for the same as before. Requirement already satisfied. That means I already installed the pandas library. Okay. Now we will here. I mentioned some description about the data set that we'll be using. Okay, in our exercise in tutorial. Okay, it's a data set. It's called Iris. Iris dataset was used, extracted from 1936 paper, the use of multiple measurement in taxonomy problems, and can also be found in the UCI machine learning repository, which is Kaggle. You can find it in Kaggle if you are a beginner to data science and a beginner to machine learning and AI. You need a resource for that experience and do exercise, practical coding on it. You can find it in what? In Kaggle. Kaggle is updated daily for datasets and approved and verified datasets for different purposes and real used data. This dataset is called Iris. It's about a flower, special flower. It have these columns: ID, sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter, and the class of the rose, the flower itself. Okay. When I downloaded the data, I found that the data have different version. Okay. When you try to implement the exercises we are implementing now, some versions have different column names. For example, sepal underscore length, okay, or sepal L, or sepal. It's have different versions. Some of the versions have class. It's changed into species. Okay. If you have any error in implementing these examples, you have to go and check the data version that is downloaded with the same column names. Data visualization. Now we talked about the installation of libraries. Till now, we talked about the data set. Now we will have this first step is to import the data. Okay. We will use two data sets, the Iris and the one reviewed later on. We will use the read underscore CSV method, which is a comma separated value. Comma separated value is easily used for analysis and processing for data. That's why they mostly dependent on comma separated value, and the size of the data will be so small, can be distributed easily. Okay. We will use it through Pandas library. Well, I was mentioned before. Do you remember that we mentioned before that Pandas library allow me to enable me to manipulate data and extract them and read them from different resources and clean them. Okay. Now we will see this example. Import Pandas as PD. Okay. I imported First, I imported Panda. Importing the Panda, as in other languages, in Java or any other language, importing will include it in the development environment. Okay. As PD, here I created an object, name it a variable object called PD, that will be representing a superclass as what? Pandas. Okay, this PD is a variable. What do I mean by variable? You can change it according to the user. And for example, if I name it X, it's the same. I will use it as X. I can change it. Okay, user defined. Iris equal to pd.read comma separated value, and iris.csv names sepal length, sepal width, petal length and petal width and class, and then WinPret iris. Let's concentrate on the read that pd.read csv. Okay, I will explain this. I use the object I defined, which is pd, to call the method, okay, read underscore csv, the comma separated value. I will read this file. Okay, then this method need what? The data source, which is the iris.cvc, the file, the data set file that I downloaded from Kaggle website. And the names of the columns, I named my columns. I can change the name of the column, sepal the underscore length, sepal underscore width, petal underscore length, and so on. Okay. Then I printed iris.head. I will print the beginning of the first 10 rows of the data set. Okay, I need to emphasize on something here, which is variables. You see, iris is a variable. Okay, variable here. PD is a variable. Okay, and I can use the dot operator to call the method inside the variable of the class library. Then we will have a scatter plot method to create a figure and an axis using plots that's plots. Okay, we can give our plot a title and labels. There is this fig and axis. This is the figure and axis. I will use in the subplot. The subplot return two objects is the axis and the figure. Okay, for the scatter plot, the output will be look like this. Okay, this is the scatter plot. I need for this scatter plot, I need the figure and the axis, the y-axis and the x-axis. Okay, this is the code. I created BLT. It's an object of the class Matplot library. Subplots. Then in the axis, I specified the two axes, the x and y, using the scatter graph. And then I assigned set the title, iris dataset, and set the x label, sepal length, and the set the y label, sepal width. Okay, now we'll see the code. Okay, where to implement the code. I'll go back and as we said before, I can. Okay, in Python I have ILE shell for Python. Okay, and then I go and choose file, new file. I write my code here. Well, again, as I said before, if you have familiar with any different Python text editor, it will be fine. But this is what the main integrated development environment for Python, the original. Okay. Here, the code and plot. Example 1, I will edit it. Okay, here the import. The first import pandas as PD for reading the comma separated value file. Import matplot library that pilot as BLT. I created an object from a matplot called BLT. Okay, then I read the file iris.csv. When I read the file, immediately I put the name of the file iris.csv. We must include the file and the code in the same folder. If it's not, it's not the case, maybe the file on the server, other server, or another folder, I need to provide the absolute address for the file. The absolute address is started from the name of the server, the folder inside it, and so on. The names of the columns, and here I created an axis and a figure. Okay, I specified the x axis and the y axis, and a title and a label for x axis and the y axis. Okay, as at the end we have what? PLT, the object.
Ms. Safia, sorry for interrupting. I would appreciate if you look at the participants' comment in the chat section.
Okay,
Some of them are asking questions.
okay, I'll go into this section. Miss Hilala, yes, you asked me why you did not just provide the name of the file to read iris CSV files. You mean we need to include the column name? I think this is your questions. Why did I need to, that's a valid question. Okay, why did I need to include the columns of the file? Sometimes I have a file with, for example, a very huge number of columns. I need to specify which columns I will work on. For example, here, in our example, what is it? Give me a minute. Here I included only the Seaborn length, Seaborn width, beta length, and beta width, and a class. I did not include the ID. Remember the data? I'll show you the data. I have the data here. Okay, I have the ID, the Seaborn width, Seaborn length, beta width, beta length, and the class. Okay, when I read the file, I only focused on those 5 or what? How many? 5 columns. I didn't ignored the first column. That's happened in if you have data, bigger data, for example, 50 columns, 40 columns, you will choose which columns do you want. And I hope I answered your question. Okay. Siri, why not using Jupyter if we downloaded it? Yes, we will use Jupyter. We will use both tools. Some of the examples we use them into using the command shell IDE, and some at the end we will have, for example, I think I remember 6 examples using Jupyter Notebook. It's more fun, as Siri mentioned. Abdul Mateen, he said, share file. Yes, we will share. You mean now? You want me to send you the file now? Can I do that, Miss Hind? What?
Yes, please share it. If we can share it here in the chat, then send it to my email, and I will share it with the people who registered their name in the attendance sheet.
Okay, okay. We will share everything, inshallah, Abdul. You're welcome. Just give me a minute to share it.
Everyone, please, can you make sure that your name is registered on the attendance sheet so I can share with you the material? I'll share it now so you can follow up with Ms. Safia. I'll resend the attendance sheet.
Sorry for this issue. I just Okay, as Miss Hind mentioned, we will this whole folder we will share it and we'll send it inshallah for everyone. All the exercises I'm implementing now, it will be included as a Python file, and you can run it and check it inshallah. Okay, then we have the what else questions. No. Sorry, Hilala. No. I said with Python. I think my voice it wasn't clear. With Python, the codes we implemented now, inshallah, will be shared later on. Okay. We reached the code here, rs.cv, and the names, as your friend here asked, you're welcome, asked the columns. We mentioned the columns by name here. Why? It was a valid question, very valid question, because we need to specify which columns to work on. Okay, and this read comma separated value is a method imported from the object PD, which is an object defined as Pandas library. Okay, then I specified a plot for axis and a figure, and specified the x. Okay, and the x and y axes, both for x and y. I specified the title and the x label, x axis label, and y axis label. Okay, at the end, we will always include at the end blt.show what the figure. Now I want to run my code. Any question about the code, you can ask me in the chat. Thank you, Ms. Hind. She told me to check the chat. You can ask me through the chat and we will discuss things together. Okay. Then to run the code, I go to run or F5. Okay. Then I have the x-axis and the y-axis and the x-axis and this scatter plot. Okay, scatter plot here. Okay, I'll try to zoom as my friend here asked me to zoom. I'll try to zoom. Magnifier. You meant the Control plus. No, I didn't find the magnifier. Okay, I'll send the code every time to check it in the chat. Okay, if it's very far, I'll send it on the chat to check it with me. Every time I explain a code, it will be easier, inshallah. Yeah. Okay. This is the output. We have the x and y. Thank you. And the scatter plot using Matplotlib library. Then we go back to the code. We have line chart. Line chart. Create a line chart by calling the plot method. We can also plot multiple columns in one graph by looping through the columns. Okay. The basic, we will have two basic components of every code. You will find us repeating them. Okay, which is the import libraries for pandas and what? For pandas and the matplot or any libraries we involved in the exercise, and we will have what the show at the end. in the middle, the code lines in the middle will change. Okay. Here we have the columns. We dropped the column class. We don't want to interact with the class column. That we dropped it. We have the X data, the ranges of the iris shape. Okay. We have figure axis plot. We have the plot column X data, and we set the title and the legend. Again, we will see the code together. Okay, before we go to the code, the line chart, we have scatter with colors. Okay. Scatter with color. Here, Al Jazi has a question. Oh. Okay. We have here the code. I send it into the chat to follow up with me. I imported pandas as PD. Why I needed panda? Because I needed to read the comma separated value file. The Matplot, I created an object of a Matplot library. Then iris equal to, here iris is a variable name, you can change it. It's not related to the file name, dataset file name is not related to it. You can use any file, and you can go inshallah for the references at the end of this workshop. There is a note on every resource for Python. It focuses on this. Don't mix the iris with the variable name. We will read the comma separated file. Here I provide the file again, iris.comma separated value. I didn't provide the address because they are the code and the file in the same folder. Okay, the names I included here, the names of the columns, the colors. Here I'm plotting an image. I'm plotting a scatter graph using with colors. The previous only one color, which was blue, default color in the Python, but in here in colors I will using the classes. For example, iris setosa red, iris and iris Virginia, I think. Okay, these classes in the last column, do you remember? I'll show you the data again. Okay, this is the classes. This is the classes. I will every data. I will draw a scatter plot. It will have a marker for each data x and y. I will have a marker. Every marker for this class iris setosa will have a different color. Okay. Here, according here, I created like an array of colors. We call it color dictionary. I created a color dictionary, iris setosa red, iris and green, and so on. Okay, then I will create a figure and axis object using. Go ahead. If someone will have a question, you can raise your hand and ask me. Subplot. Okay, for I in range, length iris tail length. Okay, scatter iris sepal length of an eye, and iris sepal width of an eye, color iris of a class. Here we specified what in the scatter method. We usually give the scatter method two. We used to give it the scatter method in the x value and the y value. Now I provide the x value and the y value and the color. The color I will get it from the array according to the class. Okay, the class name, if it was iris setosa, search for iris setosa and retrieve what the eye of the color, which is red, and will display the red dot in the scatter plot area. Okay, then again I will set a title for the drawing, for the visual iris dataset, and then for the x label and the y label, sepal length and sepal width, and we will run the code. Run the code. Okay. have an error here, the data, I think. The data. The data, I think the data is different here because the name of the field is different. Okay, well, later we'll talk about it later. I'll send you the code and we'll correct the code and send it to you. Now we'll go back to the scatter plot, the line chart, the line chart code. I'll send the code again, line chart. Follow up. We'll check now the code of the line chart. Again, I imported libraries, the Panda for reading the comma separated value, the Matplotlib, the read file, and the columns. And I have column iris drop the class, I don't want the class, and create an X data range for iris.shape. Okay, for this, we'll see the run, check the run first. Okay, for every column, we excluded the class. For every numerical column, we will draw what? A line. That happened here in the code. We have X data range for iris.shape. For every data range, numerical range inside the code, we'll draw what? A line. Okay, and the AX plot using the here also we defined figure and the axis plot subplot. This is, we will use it before in every Matplotlib example. And we have columns. Through the columns we will draw what? The plot. Set the title and X legend. The legend is the, you know, which is the legend, the description for the colors, for example here. The Seaborn length is the blue, Seaborn width is the orange, and so on. We call it, this is the legend of the description. Okay, let us inspect this figure. Okay, and this applies to other figures. You see the figure is what is a statistic, does not give me any indication when I press on the lines. Only here give me at the end. Okay, at the footer, we have the X value and Y value according when I move the line. Okay, this is one of the features that included in other libraries that the other than Matplotlib. It's not an interactive, does not include what drop-down menu, for example. I cannot group the data using something. I cannot include an event, a real-time event in the figure, and so on. Okay, here we mentioned the example of the line. Okay. The histogram. Here the histogram, create a histogram using the hist method. If you pass it categorical data like the points column from the wine review dataset, it will automatically calculate how often each class occurs. As mentioned in the histogram, we need to draw a histogram, we need element or categories and the frequencies of the happening of this event or something. Okay, we need, sometimes we call it points and frequencies, and we'll create, using these points and frequencies, we create pins that represent the amount of what the frequency, depending on the frequencies. We have import pandas, again, the import the libraries and reading the file. We're creating the figure and the axis. We created X axis, which is the sepal width. Okay, and we have here the histogram. The histogram is we will distribute X values. Okay, pens, we will have 10 pens, and the color will be what? Blue. I can choose any color. Set the title, X label and Y label, and this is what the histogram function by to create the histogram figure. We will come here to histogram. Okay, Matplot histogram. Okay, this is the code. Okay. This is the new method. This is and for most part the others are repeated, and this line is the responsible to create what the figure for the chart. Here we have the histogram for the Seaborn width. We specified an x-axis. We only need in histogram one axis, which is the x-axis, and the frequencies. The frequency, the occurrences of every data. We're supposed to have here how many pins, how many columns here in the histogram. We're supposed to have how many? According to this, 10 pins. Okay, if I want the data to be more specific, I will increase it 20, 30, or more categories. I will increase what? Depends numbers. Check the chat. This is the output of the histogram. Then we have Matplot, the bar chart automatically calculating the frequency of category. So we are going to use Pandas value count. Here we have the iris, reading the file comma separated value, and we plotted the figure. We have data equal to iris class dot value count. This is new to us. Okay? Here, when I want to count the frequencies for a special column according to classes. As the example we said we have the data set was concentrating records for the specification of different occurrences of flowers, I think irises, and then we want to count the value for each class. We use the dot value count here to count the frequency and occurrences, get the X and Y data, points equal to data.index, okay, and then AX bar points and frequency. Here we didn't use the histogram method. We used the bar method. Bar will create need points and frequencies. Points will be created using what? The indices of data. The indices of data, and frequency we counted using the method value.count. Okay, depending on the column class in the dataset. Then we have the title, the X label, and the Y label, and at the end we will show the plot. This is what the bar chart in Matplot. Bar chart in the Matplot. Again, I will send it. Okay, this example using value count, and again we will send all the data. We will run the code. Okay, we have frequency, iris, versicolor, and the classes. For each class we counted the numbers, the occurrences of these data. And for me, when I was trying the exercises, I made sure using Excel. Okay, we found that even the description in Kaggle for this data set, it's 50 for the first class and 50 for the second class and 50 for the third class, in total 150 occurrences of data. Um, this is the result. Now we'll talk about pandas. Visualization make it, as we said before, Matplot is the basis for each visualization platform or any library uh, in Python. Other libraries add more to Matplot using our higher level. We say it higher level than Matplot, make it easy to make visualization, but what dependent on Matplot. But Panda visualization make it really easy to create plots out of pandas, data frames, and series. It also has a high level APIs than Matplot. Okay, and therefore we need less code for the same result. Higher, what do you mean by higher level? I can perform, for example, I can draw a histogram figure using pandas with lower or minimum coding than Matplot because it's a higher level coding library. Scatter plot using dataset, plot that scatter, it has to pass it to we can also pass it the title. We have iris that x equal, y equal, and the title, and we can draw the scatter plot. I think most of us we tend to go use higher level languages because they require less coding and minimum lines. We go to the pandas scatter plot. We'll check the code. Again here, the same story. Import pandas as PD, import Matplot as BLT, and iris.pd. Now we use the pandas object to read the file as before, and use the iris.plot.scatter x, y, and the type. I think this is way easier. Let me send it to you. Okay. Then we plot the entire figure using only one line of code. We will see the result now. The same. I used one line of code, which is the same dataset.plot.scatter x, y, and the title. Okay, we can notice that it's sure that Panda is higher level than the Matplot. We have here the line chart. Again, one line of code. Iris drop class axis equal to 1. Plot line from iris dataset. Title iris dataset. And for the class, for each class, we will draw what the sepal length and sepal width and sepal. Betal length and betal. We have here the chart. Okay, this is the result. We check the code. The same import the two libraries. The reading of the I think you master it by now, inshallah. The CSV file, and then with one line of code, we will plot the entire line chart. For every class, I will write a line. Okay. Then we have the histogram. Again, we use the different data type, the different data set for histograms in pandas, the reviews with the plot.histogram. Okay, with plot, let's check the code first. Okay. Here I have histogram created plot iris.plot.histogram. I specified that we will have subplots. We have different plots, not a single plot. We defined into true. Okay, assigned into true. That means a flag that I will have what multiple plots in my output. The layout is 2 by 2. Okay, as a matrix, 2 columns and 2 rows, and the figure size is 10 by 10. And in every histogram we have pins, as we mentioned before. I have 20 pins in every drawing or visual in the image. And this visual, I think most of you saw this visual in research, including statistic. We usually describe the data and the descriptive analysis, the first phase of the analysis, using what histogram with different perspective. For example, the frequency in regard to sepal length, in regard to sepal width, in regard to petal length, and in regard to petal width. Here, in one line of code, I specify only parameters, the either true or false for the subplot, the layout, and the figure size, and the number of pins. Okay. Where it give type error? Maybe, yeah. You hear our friend mentioned, yes. Maybe a different type of possible data. I tried to send the data here in chat. I couldn't. I think only doesn't allow me to upload the files. Yes. Yeah. Yeah, I think the data. You can search the data. You can write on the internet iris.csv. Okay. We go back to. Okay, we have a different other examples here. The bar chart. Okay. Here we check the output first for this code. Let me. Okay. We have this is the review for the beverage. We have New Zealand and England and Germany and France and Hungary. For each review, I think the count of the review. Let's check the code. Okay, we have the included the reviews file data set. Here we can include it. When you implement the example, as your friends mentioned in the chat, we need the exact data set, maybe the different in the data set. I faced the same problem. Okay, the index column equal to 0. Here we read the file. Then the reviews that group by country, we grouped by country. In order, I think most of you are familiar with the group by function in statistic to calculate the counts by a class. We group it first, then that price, that mean, sort values, ascending falls, and we have here plot the bar according to what to each count for each class grouped by, and this what then show the plot. Then I'll send you the code. All these codes are implemented using the Panda library, which immediately you can access the method through the data, the variable that contains the data set. Okay. I hope you noticed that. Okay, I'll send the code again. As we can see that Pandas improve, reduced more functionality to processing the Matplotlib. In general, this is in general, not just in these exercises. We have the review points and value counts, sort index and plot. Here we change, I guess, the direction. Yeah, the direction of the plot. We can using the using the .parh method. we change the direction horizontally or vertically. Other visualization libraries provide this option to flip the image 90 degree, 180 degree, or something like that, but with different methodology. It's change, it specify the angle and something like that. Okay. Yeah, I'll see the code. Can okay. Here, third example. Here, I think we use the dot bar. Dot bar is vertical, and the dot barh is horizontal. Bar h meant horizontal. Here, bar mean vertical implementation. The same code, group by country, but the representation will be different. Coding only the flipping of the code, either vertical or horizontal. This is the main difference here. Dot bar at the end. Okay, we complete with the slide. We talk about histogram with plot.histogram. We have the layout, the number of plots per row and per column, as we said, 2 by 2, the number of bins, and so on, the figure size, as we mentioned before. Here, the bar chart, we use the plot.bar method before we need to count the occurrences using the value count method, then sort the occurrences from smallest to largest. We count the value that count. We used it before in the histogram in the Matplotlib. We use it on the axis, on the data axis. We used it with the class, if you remember, the iris class column, and then dot value count. Then we change it, specify the point, and then we call the histogram method. Here we can immediately call the value count, then the sort, then the plot. That bar will be vertical bars. The horizontal bar, we change the plot bar into bar h, which is horizontal, not vertical. Okay, plot plot other data, then the number of occurrences, country, and prices. This is the example we mentioned before using group by. Can group by country, then count for every group the price mean, then sort the value, either ascending or descending. Here we said ascending false, that means descending, and then every display 5 category, and every line is a 5 categories, and that plot bar. Okay, as we mentioned, it's a high level. We need only one line of code. Okay, we'll check the chat. Good. Seaborn library. We talked now about Matplot. Pandas now the Seaborn. Seaborn is a Python data visualization library based on Matplot library. It provides a high-level interface for creating attractive graphs. Okay, it includes some increase the attractiveness of the graph. If you notice that every library you can perform the, for example, scatter plot. We can draw it using Matplot. We can draw it using Pandas. We can draw it also using Seaborn, but there is some differences, some limit to them. Some allow some features attractiveness, or you can perform group by in Matplot using for loop within the occurrences. The other immediately provide a group by method, and so on. Okay. Also, to install Seaborn, okay, we go back to install Seaborn. We said we go back to the command line interface, and we write, as we mentioned, change the directory to the base folder for installation of Python on my machine. It will be different from one device to another device. And then I will write again the Python m okay, preferable installation program install Seaborn. Okay, the name of the library. Any library will be installed using these commands. Again, I have the message requirement already satisfied that I previously installed what the Seaborn and the latest edition of the library. Seaborn, we have again, we will go back to scatter plot method for creating scatter plot, and just as in pandas, we need to pass it the columns of the x and y data, but now we also need to pass the data as an additional argument because we are not calling the function on the data directly as we did in pandas. And here is a different, some differentiation between pandas and Seaborn. Seaborn, we can immediately give Seaborn the assign the x column and the y column and the data, and we'll produce what the figure. We'll see now the code in the Seaborn, the quad code. Okay, Seaborn. Okay, now we'll read. Imported Seaborn as SNS. As we mentioned before, to use a library, we have to create an object of this library and use it later on using the dot operator. Using also we imported pandas to read the file. We imported also Matplotlib to show the final plot. We have rs reading the file as before, specifying the columns, and we here use the object. This is the new. I'll send it to you to follow up with me. Seaborn. We have SNS. This is the object of the Seaborn library, and then that dot scatter plot. Okay, x equal to Seaborn length, y equal to Seaborn width, and the hue is class and data is what? Iris. Now see the result. Run. Okay, we have I'll check the code and the display. Okay, I'll specify it here. X-axis will be the length. This is the x-axis is the length. Immediately I specify in the method. I don't need to call or maybe it's higher than even pandas. Here we specified the y to be the width. The hue, the data is iris, the data set, which is the variable here. We specify if I name the variable x, the read separated value into x, and I need to write here data equal to x. Okay, but here the new is hue is the class. Can when I the hue is the coloring of the classes. Every class will have a different color. Okay, I will plot the XY data, and if it's, for example, belonging to Ars setosa, it will be blue. Versicolor, it will be green, orange, and green, and so on. This is the hue. I think hue. What do you mean by hue? Is the coloring scheme to the data or the plot points. Okay. Here in the slide, it did not include the hue parameter. This is the beauty of method of Python. You can include parameter and exclude any parameter as you want. There are the basic parameters, which are the XY data. These are the basics. If I didn't specify the hue, as in the example on the slide, it will be blue or one color because I didn't ask to be differentiate the point, the draw the plots according to the classes. Okay. Here the example with the hue. We can also highlight the point by class using hue argument, which is a lot easier than Matplotlib. exactly. If you remember, I had an error in my coding in the Matplotlib. Well, I'll send you it's corrected. Okay, because with one line of code, I drew the scatter plot and differentiate the color between. The same as Seaborn in the line figure chart. We create a line chart using SNS line plot method can be used. The only required argument is the data, which in our case are the 4 numeric columns from the iris dataset. We could also use this KD plot, which rounds off the edges of the curves and therefore is cleaner if you have a lot of outliers in your dataset. Here, as we said before, that Seaborn add more attractiveness and attractive features to my drawings, okay, to my figures. What do you mean by attractiveness? For example, here's an example. We have you can include the rounding. It will exclude the outliers. Okay, did you hear about the outliers? Outliers, um, I think the higher peaks or a very lower points in the data we call outliers. Sometimes we exclude them from the calculation. We only focused on data that is clustered to make better representation. Okay, this is the example of the line. Let's check it together. Line chart. Okay, here we have import Seaborn as SNB, import pandas, and matplot to show the final plotting area. Iris, read the data, and the line plot here. This is new. SNS dot line plot data iris drop class. Okay, and axis equal to 1. It will draw line, okay, line drawing for every column in the data. Okay, if we go back to we import the data, the sepal length, sepal width, petal length, and petal width, and we excluded what? Dropped the class. We'll draw 4 lines for each numerical columns. Okay. The output will be run. This is the result. Again, as the same applies to the previous libraries, Matplotlib and Pandas, there is no interactiveness. It's static figure. Okay, we will see, inshallah, other interactive. We have a histogram. We can SNS this histogram plot method. Okay, we need to pass the columns we want to plot, and it will calculate the accuracy itself. Okay, we can also pass the number of pins, and if we want to plot a Gaussian kernel density estimate inside the graph, we use 2 methods. Either using, if you want the density estimates as in the right hand side, or we don't want it. It's only a flag. We change it from true to false or false to true. Okay, we see now the examples here. Send it through each. Okay, can follow with me. Okay, we have density plot. One review point spins 10 and KDA kernel Gaussian kernel density estimate to false. We will run the code. Okay, we have without the density kernel display. The other example, we only changed the from false to true. Again, you can see the result. The same code, just changing the KDE parameter from false to true. It will include the estimate, the density estimate in the final figure as a representation. This is important for statistical point of view to see where is the accumulated density of point occurrences in the according to the X and Y factor and need to be included in the conclusion and evidences. In the Seaborn, we have the bar chart can be created using the counterplot method. Okay, in the counterplot method, we have the one reviews points. The reviews, according to the reviews points, we created what? A bar chart. Only I needed to what? To pass the parameter, the column that I want to create the bar chart according to this, according to it in the display. Here's the output. Again, we have the import, Seaborn as SNS, the pandas as PD, and the Matplotlib to show the final plot. We have the read comma separated file, and we plot the line using the, we drop the class, so plot the line. So the bar. Oh. Strange. It's not implemented here. Okay. We can write the SSN count plot while review points and we'll create the visual as shown. Here we have the box plot. Box plot is the displaying, for example, here the graphical method of displaying the 5-number summary. We can create a box plot using Seaborn box plot method and passing it to the data as well as the X and Y column name. Here we have the one reviews, points bigger than 95 and less than 10,000. We'll check the point here, the figure, the visual here. We have the points is distributed into 95, 96, 97, 98, 99, and 100. Here is related to the statistical method and the represented the data into groups using the quartiles. I wrote it here for you. This is the quartiles specifying the how many to which extent the quartile is going up or down in the X or Y axis for the confident interval from 95 to 100. We have different 5 quartile for each confident measures. It's 95, 96, 97, 98, 99 until 100. Okay, then the y-axis will represent the prices. Okay, it's measured from 0 till 10,000, and then point price and the confidence interval is specified at 95 here before. Okay, this is example is the box plot. Also, it's used for descriptive analysis. The box plot. Okay. After importing the libraries, we go after importing the libraries, Pandas and Matplotlib and Seaborn, and reading the file, we go and one review larger than points larger than 95 in the quartile columns. We specify the prices in the Y column from 0 to 1000, and then we plot the point prices and data, which is the data, the reviews, the review data. Okay. Then when using Matplotlib, here are the data. You have in the 95 first category, in the 96, 97. If we like, sometimes we like to enlarge the x-axis for the confident. We make it 90, larger than 90. It will include 5 more quartile ranges. Okay. Okay. This is using the wine review datasets. Also, it will be included and downloaded for you. The heat map is a graphical representation of data where the individual values contained in the matrix are represented as colors. Heat maps are perfect for exploring the coloration of features in the dataset. To get the coloration of the features include a dataset we can call dataset.correlate, which is a pandas data frame method. This will give us the correlation matrix. We can use either Matplot or Seaborn to create the heat plot, the heat map. The heat map is considered basic statistical representation of data. As it mentioned here, it's used for correlation. Correlation to correlate variables. Which means they are related to each other, not causing each other. We not say variables correlate with each other. It's easier for when I examine the visual, we can set which variables are correlating with which variables according to the heat, the coloring scheme of variables. Here the sample. Table length 1, we have the data that identical or correlated. We have in the same color. We call it the heat map according to different colors, ranging of hues. We have the minus 0.11 equal to this 0.11. With visuals, it's easy to indicate which columns are correlated with each column in certain values. Okay. Here the heat map. Seaborn make it way easier to create a heat map and add annotation to it, which called SNS heat map iris.correlate. We use this method. Okay, and annotation. It's the description of these values. We call it equal true. And here's the code. See the how it will look. Here. Again, importing the libraries and reading the dataset, and then going what? This is the new part, which is the SNS Seaborn object heat map iris correlate. This is new. Okay, the iris correlate is considered the pandas because iris is a pandas object. Pandas method correlate and annotation equal to true. Then I will run the code. Okay, we have here the annotation, the description, and the legend here, the measurement of data, the smallest from the largest, and the correlation from the colors. Immediately I know there is what? A correlation. Okay. talk about Plotly, Python, open source graphing libraries. We talk about the basic methods in uh, using Matplotlib, Pandas and Seaborn. Okay, this is not the only visualization library, but this is the basic visualization library and mostly used. We included here Plotly, Python open source graphing library. Plotly is the widely used open source graphing library. Is mainly used in currently used in COVID-19, creating interactive dashboard in the Cydia and in with Tableau, and also used in the World Health Organization to create daily reviews of COVID cases in their platform from the CDC. We have different categories of method and functionality provided by Plotly in this slide. We can go here the fundamentals, the same fundamental that provided by the three before examples, like the histograms, the figures, the scattered graphs, and the analytical dashboard. Also the fundamental functionality are included in Plotly. Also, the provide special functionality for machine learning and artificial intelligence for prediction models. We can here we have example the machine learning regression, the specific classifier, KNN classifier, neural networks, and so on. Okay, all the artificial intelligence and machine learning methodologies. We have the basic charts, also the basic not interactive charts, which is the bar chart and pie chart and so on. Statistical charts, which is the error charts, and when we inspect the data for abnormalities and outliers outside of the normal distribution, we use charts such as the box plots. We just used it, and histograms and so on. Also provide scientific charts. Okay, the heat map, the ternary plots, and log plots. All these are what scientific charts. We will have also provide financial charts. We will see the revenue. We can check the waterfall model for the revenue and the funnel chart and so on. These are financial charts. The net present value and those visualization. Mapping the spatial representation of data according to maps and locations, and graphical geo require annotation on a map, data annotation on a map, or usually these are the interactive interfaces for create for when I have, for example, I want to create a chart for the certain how many payment or for example consumers, how many consumers I have in my branches in a certain area according to my map, the distribution of my branches. I can use what map representation for every branch, how many customers, and it will be on data on a map. 3D charts also represented using the Plotly. We have the subplots. We have multiple plots together distributed. We just opened once. I didn't explain it yet. When we have, for example, when we had 4 histograms in the same graph, I can represent that the data in different perspective at the same time and view it and have different views of data in a single chart. Here, for example, here we included sometimes we include the raw data with or summarized data with a representation of this data using an histogram. I can check the histogram and go back to the summarized data for more information especially in decision making dashboard. Okay, the Jupyter widget. Okay, the special widgets for Jupyter are included here in Plotly. Also, the transformation, filtering, a group by, aggregation, multiple transformation. These are included also in the Plotly. What do you mean by transformation? Sometimes, for example, I want to display on a map the result of, for example, new cases of COVID within the previous week. Okay, I change from a drop-down menu. Change the specification. I transform the data into only the display the data only in the previous week. Okay, I include a new transformation. I added the dimension of time. I can add the location dimension, say, for example, in Jeddah city or in Riyadh city. Okay, I included another transformation parameter. I transform the data, display data into another reference. We have custom controls, and this is important. Custom controls. We will implement some of them. For example, if I need the data picker, if you know the data, I want pick certain data. I want to pick a certain location. I want to include the drop-down menu. I want to include a slider. I want to include a magnifier. Okay, these are what we call them custom controls. It's not related to static, but it's related to representation. We have animation. I also included different animations in the library. Just give me one moment. Um, as your friend mentioned in the chat, okay, one of the audience mentioned that when we are going to use Jupyter notebook, now we will use the Jupyter notebook. As I mentioned before in the installation, I said I depend on the Anaconda distribution. I downloaded the Anaconda executable file and then install it using a straightforward next dialog dialog installation. Okay, then when I finished installation, when I search for the file, for example, Jupyter, I have what? Jupyter Notebook Anaconda 3. Okay. Okay, I run the Jupyter. Okay, we have the Jupyter. It will act as a local server. You can notice that I'm running Jupyter on what? On a web page. Okay, the web page starts with the local host, and then what the port, and then what the tree, what is the base of Jupyter. I think if you are familiar with servers and Apache and server-like environment, Jupyter settles on a local host process on your operating system. Okay, then you can move it later on into a server and it will work fine for your consumers to check the data. For example, if you're creating a dashboard for people to check on the internet. Okay, make it easier. We have folders that contain the 3D objects, the all the folders, mainly some of them in my computer already, such as download, Eclipse. I have Eclipse on my computer, just in mind, and so on. Okay. Uh, okay. We can here start Python editor. We can create a terminal, access a terminal. Okay. I went into the terminal. Okay, same as the command line interface does, but now I access it from the local host inside my machine. Okay, here I can write the same command, for example, cd, and write the length. And remember, when we installed the library, I wrote pip install matplotlib and so on. I can do the same here. That's why I told you you can install. There are different ways to install the libraries and different methods. You can follow whatever you want. Also, you can create a new Python code notebook. And here is the notebook. We can create here, import a new code. We can insert a new cell. We can cut it. We can paste it. We can save it for later use. I can open code. For example, I store it where I store it. I can navigate where I store it and open the code. Okay. We can go into documentation. That's why I told you we included Jubiter, because it's the most used editing text editing tool for Python, because especially for educational purposes, since we as we narrate, we execute as we narrate. Okay, now we'll run one of the code. Here I have this code imported. I can copy it and write it in the Jupyter notebook, and then press run. Wait a minute. Okay, let's start with the code that already I prepared for you. Okay, here we start with the Python open source graphing library. Okay, here this code, if you can see it. Okay. Can we take a break and return after prayer if that's suitable, Ms. Hind? Is it suitable for you guys? We go after prayer, inshallah.
I think so.
Okay, come back, inshallah. Yeah, okay, we go pray. I'll keep the recording open. Inshallah, we go after prayer. Thank you all for attending, and we'll go after prayer. Assalamu alaikum. Go ahead, Isra. Go ahead, Isra. You raised your hand, I guess, if you need something. Okay, now we'll complete. Let's wait for 2 minutes. Okay, we go back to what we were talking about. We reach the library Plotly by Python, which is an open source graphing library. You can see the comment and the history behind it in the community section in the python.org website. It started to was an initiative to accumulate all the functionality needed in different disciplines. Okay, as we mentioned here, we have different services included in Plotly, the Python, and here we have we'll discuss some of these functionalities and some of the applications used and implemented through Plotly, and encourage you all to go, inshallah, and read this resources I included at the end of the slide. It's very interesting, and I think it's very necessary for as a scientist in general in data science, and if you're interested in Python, it's very interesting. Okay, here the first example will is an example that plot the bubble charts with color scale. Okay, these examples are interactive. Okay, and can be embedded within web pages using widget, or can be embedded within JavaScript using triggered by an event in JavaScript, and so on. Okay. What is a bubble chart? A bubble chart is a scatter plot, is another type of scatter plot, but called bubble chart because it includes a third dimension of the data is shown through the size of check the mic, the size of a marker. Okay, each as you know, we discussed before, I think we mentioned that scatter plot, every data represented in the x and y point in the scatter plot, we call it a marker. Now I put a dot in the scatter plot, we call it what? A marker. In this marker here, the marker is modified and include the dimension, the color, and the data, the size of the marker. Okay, the size of the marker represents different any representation. For example, the effect maybe represent a z-axis, another column of data, x, y, and another z column of data, represent the severity, represent anything. In the following example, we have import Plotly graph. First, we run the code, and then what? Explain using the figure and the code. I will copy the code, Okay, put it in the chat for you. No, it's not done, Asrar. No, I just started after prayer. I just started. Okay, I have here. This is the code for the bubble chart, and we will implement it using Jupyter. You can implement it using the IDE the terminal back terminal we used to code on previously, but it's recommended to implement these codes on the Jupyter because it's allow us to exclude it into uh, web page, as we said, HTML widget or iframe. You can include it in your website and so on. Okay, you already tested it in a web browser. Now I'm using a Firefox. You can use any browser. Okay, how did I run Jupyter? I just wrote in the search, since I installed Anaconda in in my machine. I can type Jupyter, and it all immediately pop up Jupyter Notebook as an app, and I'll press it and it will open displayed as the as from a local server, local host. This is the port number on my device. Okay, now I pasted the code here. Now when I run the code, I have here a bubble chart. Okay, uh, this is different from previous figures. When I press on or hover over an object or a marker, it's an interactive. It give me display the point of data with according to color, and we have here the chart. Okay, this is one of the features of we can zoom and zoom out. I can lasso, I can do everything, auto scale. Okay, I can do all these things. I can include this plotting area into my website using HTML widgets. Okay, here we have the import Plotly as Go. I imported the Plotly as I did with all the previous libraries. I import the library and create library. Now I created Go as an object variable from the library Plotly. Then this is a variable figure, and equal to go.figure do go.scatter and x and y. Here you don't see importing data set using a comma separated value data set downloaded for somewhere. We created our data, which is dots 1 about 1 and 3.2 and 3.2. I created the the data value, the x value for all the dots, the markers, and the y value for all the markers as a two-dimensional array. Okay, this is a one-dimensional array, and this is all of them are two-dimensional array. The mood, the mood for the figure, okay, it's a scatter plot. The mood is marker. It will be created as a marker. These called are markers. And for the marker, you see how we narrate the coding. I can implement each code separately. Marker, we have the dictionary. Dictionary for what? For colors. Okay, we will use the dictionary, which is a multiple dimensional array for representing different dimensions. For example, here we have the color. Okay, we have the color. This one-dimensional array is a part of the whole overall dictionary that will be implemented on the markers. Okay, the color, we have 120, 125, 130, 135, 140, and 145. This will be what the colors for the dots I defined previously using the XY data. Okay, the first point x1 and y1 will be used the color 120, and when we go as in if you studied HTML or CSS, you can find in the W3 schools, you can find the chart colors using his hexadecimal. Also, Python provide this library Plotly the website for Plotly provide a chart for the colors you can choose from it. And here we choose colors 120, 125, and so on. This point 1.1, this point 3.3, 3.2, 3.2, and so on. And find here in the one-dimensional array for X and one-dimensional array for Y. Then the function figure will use what the dictionary for colors to color these markers. Okay. Also, included in the dictionary, we added another dimension, which is the size. Okay. For each point, I can decide the size for each point. For example, 15 for the first, 30 for the second, 55, and so on for each point. Usually, the first point is the smaller, the larger. It's for your own visualization, your own perspective. Okay. For example, if I change this, use into 50 and run, we can see this node, the size of this node, marker, sorry, is increasing according to what the dimension of the size. Okay. Then show scale is true. This flag representing the scale here on the right hand side. The scale for the maybe represent the severity, represent the increase in population. That's why I know it's the smallest value is 120, represented by this color. Immediately I can figure this from the graph. Okay. At the end, we used what? Figure.show. It will display the specification of this figure using the as we used before in the data plot. You remember that. Okay. We can notice here that we use the go.scatter. Scatter is considered a method within object from Plotly to display scatter visualization, including specification for colors and size and other dimension, not just only these dimensions. This is as an example. Okay. The second example here we'll discuss also within Plotly. We can open source again. We have the Waterfall, which is a financial application. This is an example of financial charts using the Waterfall Charts. The Waterfall Charts are also commonly used in financial analysis to display how a net value is arrived at through gains and losses over time or between actual and budgeted amount. Okay. As we see here in the graph, waterfall represent what the rises and the fall, or sometimes we call it the, as he's mentioned in the slide, the gains and losses, the revenue or cost, okay, in your business or in your financial data. Okay, usually the waterfall we represented in two axes. The amount here represent the amount in usually currency, and the time axis against the time axis. Okay, we have here the example as we used before. I will implement the example. I send it to the chat, and I will implement with each other. Okay, going. Okay, we have a question here. Can you use your iris dataset in Plotly? Yes, you can use an iris dataset. That's a valid. You can use using Plotly. You can use data that is uploaded locally to your device. You can, one of the main uses of Plotly is using an external data from another server. That's why it makes Plotly more applicable to a web-based application. For example, what do I mean by another data set on another server? For example, if we have the iris data set, imagine that this iris data set represents a financial banking data for different branches. For example, Bank Rajhi. Okay, Okay, everyone updated this file. Where should I put this file? Either a central repository on the server or distributed. Okay, Plotly can access when I specify the database or specify the server and specify the name of the dataset. I can go to this address and extract the data and display it. And I think according to specialty, maybe let me guess the specialty of the audience. One way or another, through your career, I think you will need to implement such a tool. I think, and according to, I guess the background or the who are interested to attend such a workshop, one way or another, one day you will need to implement such a tool, because nowadays, for example, currently in our days, in collecting data from different clinics about the cases of COVID and updating a central repository, and the repository immediately will display the result to decision makers and government representative. Okay, a good question. Thank you. Okay, I'll send the code now. Maybe missing something. We go now executed. And we can mention that it's also the preferred tool for training and education in Python. Okay, we have here the same. We import the Plotly as Go, import the library and create an object. Figure, as the previous example, we created also a figure, go.figure. Then we insert the figure element. We can specify what more in details, the type of figure that we are using. Figure, go waterfall. Previously we said go scatter. Okay, here we say go waterfall. Now to specify the specification of a waterfall, this is the waterfall in front of us. Okay, the first axis, the x-axis, represent time series in days, in months, in weeks. Here it's represented into quarters of the year. For example, I want to calculate losses and gains for the first quarter of 2017, the second quarter, the third quarter, and so on. Okay, we have the initial, represented the total, I guess, and this is the gains, and this is the fall. That we call it the waterfall. Here represented in red is the losses. Then the total after the total gains and the total losses will be this total. And there is the second year we have gains and then losses, and this is the total. Okay, as we mentioned before, it's an interactive. I can press and check the data. For example, here when I said it's a loss, it's in 2017, the third quarter of the year, 35, and you see the arrow indicating we are down in this financial area. Okay, we'll see the parameter used in the waterfall. X representing the data representation. Okay, we have 2016, 2000. Okay, the second dimension, the array row, we have the initial quarter one, second quarter, third quarter, and so on. Okay, for each, as we mentioned before, remember the marker and the color and the size. The first point will take the first color, will take the first size, and then again, the second point will take the second color, specified color, and the second size, and so on. The waterfall, the same. In 2016, in the initial in 2016, okay, initial in 2016, then the 2017 will be divided into quarter one, quarter two, quarter three, and the total. 2017 quarter one, 2017 quarter two, 2017 quarter three, and so on. Okay. Measurement, absolute. The initial value is absolute, and then what? Relative, total, relative, and how to calculate the value. Okay, in the initial values and the total and the total calculated as what? Here are total and absolute value, and here are relative value because it's relative to previous losses, previous gain. Okay, as relative, not an absolute. Here y, we have the x 20, 30, minus 10, none, 10, 20, minus 40, and none. Here we have the base is 300. This is a financial equation. Okay, the financial equation to calculate, for example, net present value for a single quarter of the year or is a period of time. We need to calculate the discounted rate. Okay, if someone familiar with this, a discounted rate, it's how I can use it to expect to get an estimation of how much I will gain in this time or how much I will lose in this time. Okay, and this is considered what the discount rate. Notice that in the period we lost, it's by negative. The discount rate can be by negative. We have minus 50, and the total, of course, it's not implemented in a discount rate, none. We have the base. Also, this is a financial element. It's the base of my calculation 300, decreasing and increasing. Then another one-dimensional array represents the coloring scheme. You see the coloring scheme used here. For example, the bright blue and the this greenish teal, I guess, and this is reddish color. We specify it here in the decreasing value. If the value is decreasing, it will be color is maroon, line color red, and width is 2. Okay, this block, this bar, since it's decreasing, the color is maroon, line color is red, and width is 2. Okay, when I increase, I change the color is teal. Okay, this greenish color. If you concentrated that in the coloring, okay, the decreasing, when I decrease or increase, we have different parameters specifying the marker color, the line color, the line around the block, and the width. Okay, but it's optional. I can omit some of them. I can omit it and include, like in the increasing, we only concentrated on the color. The coloring, we didn't include color for the line or width of the line. Okay. The total, the total, which is the total of the end of the period of time. We have the color deep sky blue, and the line is color blue, and width is 3. This is the borders of the block. The final figure, update layout, title. Here I put the title. Title is profit and loss statement. Waterfall gap 0.3. This is the gap between the waterfall and the title. And then at the end, figure dot show. I showed the figure, and this is a financial example on using Plotly. Just give me 1 second. Okay, sorry for that. We go back to the second exercise. You can here you can implement other very interesting exercises in the financial chart. You can find it here in this section. I get this image from the website. Okay, for each code, for each sample of function, you have a special code for it, and you can implement it very easy. And resources for Python is everywhere. You can go and implement them, and there is different schools and different methodology. And because since it's an open source, it's very relaxing. Okay, then we have service plot with contours. Okay, a topographic map is highly accurate map that can show nature, terrain, and man-made objects like building and roads. Here, like we plotting a topographic map representing the like map of terrain, the nature, a real life area or real life representation. Okay, then we have a contour plot is a graphical technique for representing three-dimensional surface by plotting a constant Z slices called contour and two-dimensional format that is given a value of Z. Lines are shown for connecting the X and Y coordinates where the Z value occurs. Here represent what the topographic map.
Sorry for interrupting, Ms. Safiya. Can you please
Yes.
raise your voice up a little bit?
Okay.
Thank you.
Sorry for that. Okay. We go back for this service plot with the contours. In service plot with contours, we have a real life representation of a nature area or a region. Okay, with concentrating on what the Z value. The Z value, when I represent this map, maybe the Z value, if this map represents the heat, for example, degrees of Fahrenheit or Celsius in each region, it will the Z factor represent Z factor represent the heat values and so on. Okay, it's an converting the two-dimensional representation into three-dimension as the image shown here with representation of in a map in a nature way. Okay. But import, we have, let me send it again. I can send it through the chat. Okay, here an example to what your friend asked me, our Miss, I think, yeah, and she asked about do we can use Plotly with data sets, other data sets. In this example, we use data set from another server that is uploaded to GitHub coding. Okay. And you can find a lot of data sets in GitHub and in Kaggle, as we said, and also PubMed, also in government and institutes and universities. Here, the import Plotly. Oh, import pandas PD because pandas we have a comma separated value, not a generated values such the previous two examples. We have the data comma separated value, which is primary elevations in what on a server what's in GitHub. Okay, it's uploaded in GitHub for practice. Okay. We read this file and imported the data into the Z underscore data variable. We define the figure as we did before, go.figure data go.service Z equal to the data values. When we need these data that values we extracted will be the service. Okay, update pieces. We have the contouring, show true, use color map true, highlight color lime green. Okay, we have highlighting the lime green data. Look, when you interactive, you can what? You can see the lime green. Let me zoom. Here, when I choose certain areas according to why it will what highlight on the of the map. Project Z projection of Z factor Z axis is true. Okay, update layout title. This is the title. Auto size false. What I mean, I auto size it. Cannot auto size the image, the map. Okay, scene camera I. Uh, this is a dictionary, also dictionary X, Y, and Z. I think the camera is the angle where I look at the map. Look at this is the angle where I focus my focus, camera focus, or viewer sometimes we call it. This is what the camera is specified by X, Y, and Z. Okay, X 1.87, Z minus, usually minus if you, because I'm looking like I'm looking from down the image, we call it why the Z by minus, because we assign the value under the image, and I hope I was clear by that. Width and height 500 and 500, and the margins we have the left margin, the right margin, the bottom and the top. All these are decorative or formatting for the design for the image and how to show the image. And then at the end we will have what figure that show. In Plotly, there is a manual for every method that is provided for for example this the object, the map, different maps. We can make a flat map, all the continent. It's something like this, and we can specify. Okay, go to the chat. Oh, okay. So sorry for that. The whole code. I didn't send the whole code. Okay, now we have two still two examples. Click event in Python. Okay, click event in Python. We said Plotly allow you to the interactive event within the visual representation itself, not only in displaying information like before, press on the mark to display the x and y value and the color and something like this, or coordinates, not just the coordinates, and there are events. Okay, for the event here, allow user to register different event handlers on a data series and data points, legend and chart. I can, they have the x and y coordinates specifying, for example, time or a date. Sometimes on specify a certain event on this plane, I can click and specify event and interaction. Okay, we will send the code. I think the chat omit some of the code, I think, right? Translation. Okay, here for it. Okay, now I'll take the code and see the output first. As you can see here, as a narrative, it give me different input. I can increase the input, I can reduce the input, okay, according to that. Okay, here we have events with coordinates. For example, for this coordinate and this point, okay, I can press on each event, okay, and inspect it. I'm choosing events, okay, through imagine this is, for example, the y-axis as the time, frame, and then we have here, for example, the date here the days, and here the time. I can specify at which time I will arrive, for example. Or choose in this month, for example, the date, a certain date, then I choose an event in this date. Okay, this is clickable events. Also, it's can implemented in JavaScript, in Perl. You can implement such functionality. JavaScript allow this. Now we have the import the plot. Here, import NumPy. Okay, this is new to us. Import NumPy. NumPy is a Python library that allow me to create random numbers or data sets. Okay, I want to create random numbers from, for example, 0 to 1000. Between each, the increment between these numbers is, for example, 5. This function implemented in Python using, I think every language have a random number and data series generator. Okay, in Python, I can accomplish this using a library called NumPy. NumPy. Here I imported NumPy and created an object called MB. MB.random seed1. Okay, I created a random object also. X and Y. X and Y, it will be random numbers from 0 to some extent, from 0 to 100. Okay, 100 is here is 1. From 0, 0 0.1, 0 0.2 till 0 0.9 and 0 until 1. Here is represented as 100. 100 random number between 0 and 1. Okay, and Y the same thing will represent the random numbers from 0 to 100. Then I created an if variable equal to go.figure widget. Okay, now I created, let's show you an example. Okay, here an if go.figure widget. Here I use a figure widget. We didn't use a figure widget before. Figure widget return an object with these following specification into the variable f. Okay, we'll create an object with this specification and return it into, assign it into the variable f. And we will say why I said that. Okay, in shortly. Go.scatter. I want to create a scatter. This is a scatter graph figure. Scatter x equal x, y equal y, and mood marker. Okay, the mood is a marker which is dots. Okay, and the point for x and y, when x equal to x, they are randomly assigned. We'll create a dot point. Scatter f dot data. Okay, we'll use this data, f data. Then that is created with f. Colors, we have now a color. We will create color for a figure widget. We create colors using choosing colors using hexadecimal colors, and then there is a multiplication by 100 to create different hues. For example, when I press on the color, it will change the hue of the point and change the hue. That's why I multiply it with 100. Scatter marker, the colors. Then now the marker of colors will depend on the variable colors. The scatter marker will use the colors that it defined previously in the variable colors. Okay, now we build in our object. Then scatter marker, that size. The size here, 10. Again, multiply by 100. Why it's multiplied by 100? 10 represent the size. Okay, as it's increased, the points will increase. Let's try. For example, I said 50. Run. Look at the point. They increased. Why I multiply it with 100? 100 because the is 100 by 100. The x is 0 to tell 100 points, and the y the same 0 till 100 points. It's a scale and area 100 by 100. Then if that layout dot hover mode, then we have a layout have different move, different properties. When I hover, we represent closest. Okay, when I hover, it represents what? The X and Y. Let I return this to the X and Y representation. When I hover, I didn't click here. Okay, where I reach, hover. Then creating our callback function. Okay. The callback function, when usually the callback function is defined when I need to trigger an event, trigger this, execute this function upon triggered event. Okay. Our event in this state, in this example, is when I click on a marker. When I click on the marker, the code of the callback function will be executed. We call it the update point. Okay. When I click on the point, the color of the point will be updated and the size of the point will be updated, and it will stick to this. Now it's all updated and stick to this state. Okay. The event is clicking on the marker and the code is the update point code. We have trace, points, and selector. These are built-in methods to trace the mouse and the points that is clicked and the selector that isn't selected. Here we specify the list scatter that marker colors and the size is equal to the marker size. For our I in points in point ends, we have CI changing the color and the size, we increase it from 10 to 20. Okay, this is when I click. When I click on the point, we will call back the function with f.batch update. We updated the f. I said here the f. We give variable because f represents the scatter object. Now I want to update it with the new color and the new size of the marker, and then one that press f.batch update. They updated with the following: the scatter marker that color equal to C, and the scatter marker size equal to S. I change the color to the new color specified here, and let's change the size into the size specified in this variable. At the end, scatter on click. On click, this is the trigger. We said that the update point will wait for an event to happen to trigger the execution of this mode, and the update point, and then F. Okay, we'll check the chat. Give me a minute. Okay, go back here. This is the first time, I think the first example, we didn't use the fig.show. Okay, fig.show. We always use the fig.show here. We didn't use it. Okay, in Python, when we use when assign the object, okay, when we assign the plotted object into a variable, we save it into a variable. Where did we save it? Here. F equal to, go to figure widget, and I started creating the widget and assign to this variable. At the end of the code, I need to display this variable by writing down the name of the variable I what? As I say, print F, or display the content of F. Okay, and this is one of the many mistakes that we do as a programming with Python. Sometimes we forget that we mention here F. We forget to write F here at the end of the code to display the figure, and it will display this type of error, display a blank screen. Okay, another mistake, we sometimes write with fig.show. If I wrote here fig.show, it will not show anything. Again, blank screen. Okay, this is the difference between the implementation. He does not have a fig show. Okay, another example here. we have a simple short example. We have ternary plots, which is a scientific chart. Scientific chart. Ternary plots are depicting the ratio of three variables positions in an equilateral triangle. Okay. We have, for example, here in this graph here, if I ask some of you, where do you think the class here, for example, I have which class represent more clustering of cases, or how we have cases, we can, looking back into this plot, we can figure out it's the coder, I think it's cities or something. This city have more cases of something, okay? Since this plot, it's a ternary plot, it's a scientific plot. Here, it's what? Okay, here there's a code. Let's send it into the chat and go to implement it again into the code. And we have, okay, you can see now all the examples are executed. It's already in the in the Jupyter, because it's a narrative. Like, for example, I want to display something, I'm going to do again the data, the same data, I want to change, it will include it as a narrative implementation. Okay, this is the figure. Again, it's an interactive. Winners, and this is an election data. Yeah, it's representing election for I think I don't know, mayors or something. The winners of this in this place, in this area, and how many votes represent how many votes. Okay. Import plotly.express as px. The data. Okay. Here we don't have a data set that is linked to a server. We don't create using NumPy data set. What did we do? We used the data definition here using data.election. Okay, data.election. There is multiple data that is built in Python that we as samples. Same as in Oracle, in IBM, there is sample data sets inside the Python installation. We can call it and extract it using the data.election method. Okay. The data.election will be extracted from Plotly repository and be saved into the f variable. Okay. Fig, now here we created the figure, px.scatter trinity. The scatter trinity will create a scatter plot using markers, but in a triangular area for plotting. We'll use the data. Okay, we will use the a date, the corner represent A, the upper corner represent the jolly, and B and another, I think, candidate, and Bergen the C represent the other corner, and the hover name district. In the hover, we name in the what, the district. The colors, winner, size, total, and the size maximum size is 15. The discrete map, we have jolly represent blue, and the second candidate and the third candidate will have different colors. At the end, we use a figure plot. We use it as figure dot show. It's a simple example with different data representation. Okay. We have the last example. We will explain. I think we are reaching the end of the time. I will explain it here. Just fast and then go back. We will end the session. Okay, this example will give me an object Okay, we call it the basic elements in a graph. Okay, what do I mean basic elements in the graph? For example, if I when I want to create a drop-down menu, I want to create a slider, I want to create a color picker, I want to create a date picker, I want to create a group by checkbox, and so on. This inside the graph. Okay, we'll run. Where did I put it? Give me 1 minute, please. Okay, here we created a slider. Yeah, we create an axis interactive object inside the graph. I can change the scale, I can pick the color, pick the date, allow the user to interactively select which type of data, and introduce different representations. Okay, uh, here we have I'll pick new things. For example, we have the arrange here. We used NumPy. Okay, that means we create the data inside the code. Okay, here we use the NumPy, not the random function, we use the arrange function. We'll create numbers from the minimum number is 0 and the maximum number is less than 5, and the increment is 0.1. We can see this here in the data. We included in V. You can see the V equal to 3.9. I will not reach 5. The minimum value will be 0. I will not reach exceed what? The 5. According to if I increase the what we call it the tighten these waves represent the waves in the cosine and sine methods. Here are the cosine and sine method. This is the sine, and we have the sine methods. Okay, we do not reach the 4.9, maximum 4.9, and the minimum is what? 0. V is equal to 0. This is represented in the arrange using NumPy. The trace, we will create a scatter, visible, false, line, the color of the line, and the width. Here, visible is false until we move what? The scatter or the scale. We move the scale, then it will change into what? Into true. The same here as arrange from 0 to 10, and the increment is 0.1 for the what? 0.1 here from 0 to 10, but 10 is not included, and the increment here, the measurement is increased by 0.1 scale until we reach the 10. What else here? We updated when creating add slider upon. We use the dictionary, which include the property and specification of these points. That's it. We specified here the title. Slider switch into its variable. It changes. Okay. I change the slider. It's changed according to the slider. It's represented in the string I. Within the range. This is for going through the ranges from all the data. Okay, we can stop by here. End of the slides. Last example. At the end, I recommend resources such as Python for data analysis, published by O'Reilly, Python Data Science Handbook, machine learning pocket references, data science for business. All these include very creative and up-to-date implementations of Python. We also the I think the Web of Data Scientist. It's an online website. Also, all the Python itself, the community and the documentation have a strong manuals and examples. I took from most of my examples from these websites, and it will be a very good learning environment for you. Okay, any question or anything? If someone wants to add something. Okay, give me just 1 minute. If someone have any comment.
Thank you so much, Ms. Safia. We want to give the floor to the audience. If you have any question, feel free to ask Ms. Safia. Do you have any question?
Very, I'm honored to be here and welcome. I'm very welcome. Any question? Thank you, Hilala, and thank you, Asim and Nadawi. Thank you, everyone. Thank you, Mr. Ishrat and Rima and Sally, and thank you for Abdul Aziz, and thank you for and Engineer Hamoud. Thank you, everyone. Inshallah, as Ms. Hind mentioned, that we will send you the recording. Go ahead, Ms. Hind.
Thank you so much, Ms. Safiya, for the great presentation. MashaAllah, excellent and very informative. You talked about mostly all the libraries related to data visualization in Python. We really appreciate your effort today. And on behalf of IDLab, we would like to thank you so much and thank also the audience for their commitment and interest in registering to this workshop. Inshallah, we will send you the recording. The whole session was recorded. So we will send you the recording of the session, inshallah, by email as a link to our YouTube channel, as well as the certificate of attendance. And I would like to mention as well that we have another workshop that is scheduled next week, same time. It will be on February 23rd, which is related to machine learning. So if you're interested in machine learning using some of the easy tools like drag and drop some algorithm, then you would be interested in joining our next workshop under the technical training program. For all of those who are registered for this workshop, I'll send you the invitation link to the second workshop. Thank you so much. If you don't have anything else, we will conclude the session.
Thank you, Ms. Hind.
Thank you.
Thanks.
Okay, thank you so much. All the best. Assalamu.